All right, distance learners, to get your points from me today, you need to do the ones I do of these first 12. I'm not going to do all of them. All right, and then you, as usual, just send me a pic. The guys in class are going to help me out. So first of all, we're going to write what I would call your best friends in this chapter up at the top, the perfect squares. One is a perfect square, but it's not helpful, so we're going to write 2 times 2, 3 times 3, 4 times 4. You can use your calculator to create these. When you take your little mini test next week, I would suggest writing these on the top of your paper before you start. And if you don't know them, just go to your calculator and go 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. And I'm going to quit right there, but it goes on out forever to infinity. Like 97 times 97 will be in that list. Anything times itself. But the numbers aren't going to get super huge, so it'll be fine. All right, so we are going to start with 144. The first thing I would suggest you do with all of them, because sometimes, not very often because it's too easy, but sometimes this is in the list. And to decide, you do on your calculator. Who's got a calculator out? Amari will do it for us. I would go to your calculator and just do the square root of 144. So if it goes beyond, maybe your teacher had you write 121. I don't know how far they had you list them out. But if it goes past that, go do the square root of it on your calculator first. And if it's nice, that's your answer. Just won't happen very often. Was it nice, Amaria?
Yeah.
It was a nice 12, wasn't it?
Yeah.
That would have been the 12th one on my list. Here's 11 times 11, 12 times 12, etc. So best case scenario, it's nice, but that's going to happen maybe once or twice on a test because that's too easy. Your calculator just does it for you. So then the next kind, we'll go right to this one is, well, what if it's not in my list? I don't see a 48 in the list. What that means is somewhere in here and its root is not nice. So what you have to do is find the biggest one of these that goes into it. And I would start here. Does 36 go into 48? No. 25 times 2 is 50. I'm already over 48. I would try 16 on your calculator. If it doesn't work, and by try it on your calculator, do 48 divided by, so I'm going to write a little arrow here, 16. If it's nice, I found my winner. If it's not, then I try 9, then I try 4. Is it nice? It is, Presley, right? What is it?
3.
Yeah, it's 16, and when you divided it, 48 by 16, you got a perfect 3. So what that means is you can break it apart into a nice one and a loner. The loner is 3. 3 is not in my list. It's got to stay in my answer. But what is the square root of 16?
4.
A beautiful 4 is going to pop out, and it is done. So let's go try number 4 next. All right, when there's a number out front. All you do is write that number down. So it doesn't make it any harder. You just, if it's outside of the root, you'll love it. Then you go to your list and you say, do I see a 54 in my list? No, but I would have passed it right here. So what I'm going to do is check the numbers from there on down. If I know without a calculator, then I know 49 doesn't go into 54. That's silly, right? I know 36 doesn't. I know 25 doesn't. Maybe I'm not sure about 16. So go to your calculator and do 54 divided by 16. Amaria's doing it for me. If it's nice, I found my winner. Is it nice or ugly decimal?
It's a decimal.
It's ugly decimal. So then that didn't work. So I could just see that these didn't work. Maybe not so sure. If you're sure, like if you're like, I know it doesn't, then skip to the next one. Does 9 go into 54? It does. If you weren't sure, you'd have to do 54 divided by 9 on your calculator, and it'll give you a nice 6. So what you're going to do is replace root 9 with its root, which is 3. Just don't forget that this problem had the 2 out front before we even started. So this is 2 times 3, which is 6, times the square root of 6. How are we doing so far, Kelly? All right, we're going to skip to number 6 because that's when they threw variables in. Right? Throwing the variables in doesn't really make it much harder. You just have to know a little trick for it. So the first thing we'll do is deal with root 40 just like we did on these last three. We go to our list and we say, is it in our list? No, right? So then we look this way. Again, mine's getting a little messy, so I'm going to grab a different color just so distance learners can kind of follow better. I'm going to think about where 40 is, and I'm going to look this way to find the biggest number that goes into 40. Does 36 go into 40? No. Does 25 go into 40? No. Does 16 go into 40? If you don't know, check it on your calculator. Does 9 go evenly into 40?
Yes.
No. 9 times 5 is 45. 9 times 4 is 36. Does 4 go evenly into 40?
Yeah.
There's my winner. All right. So root 4, root 10. And then I'm going to do this a little different way. I'm going to write these each separately. I'm going to go square root of x to the 6th, square root of y to the 3rd. Your teacher might not have done it this way, and that's totally fine. But I'm going to break all of that up. All right? So, do you remember from the notes, Presley, what Mr. Monahan said to do when you have the variables to powers? Do you remember the little trick for it? Dividing by 2. Yeah, there's a little invisible 2 out here. When you get to algebra 2, they'll have like cube roots and fifth roots, and you'll see the number. But a square root, it's just assumed you know that it's a 2. It's like squaring. It's like the number 1 in multiplication. Like I don't say Jackson is 1 times 16. It's just assumed when I write, or 15? 15. It's just assumed when I write it that there's 1. Right? That's the same thing with the square root. But you might want to put the little invisible 2's out there. So now I'm going to go clean this up. Do I know the square root of 4? Yay or nay? That's a 2. Do I know the square root of 10? No. It's not nice, and nothing nice goes into it. So I'm going to put it off to the side over here because I'm going to have other stuff that comes out and stays in. So root 10, I can't do anything with. Do you remember, Presley? So you said that there's a 2 out there. Do you remember what you have to do with the 2? Like, do you remember what I do with this 6 right here and this 2 right here?
You split up the 6?
That's how they first taught it. They said split it up into x squared, x squared, x squared. But there was a shortcut for it. What do you just do with these 2 exponents?
Subtract.
You divide them. You want to know how many groups of 2 there are in here. What's 6 divided by 2? A perfect 3. Anything that's even is going to come out perfectly, which means there's no x's that are going to be left under that root. When it's odd, though, you're going to have a leftover. Because whenever you divide by 2, an odd number by 2, you always, not only do you always get a remainder, you always get the same remainder. 1. So, how many 2's fit into 3? 1. So 1's going to come out with 1 left over. So the odds leave a loner inside. So see if you can figure out the z's. How many 2's fit into 7 without going over? 3. That's what's coming out. But it was odd, so there's 1 left over. Does that make sense? It's a nice little easy shortcut. We're going to go next to number 8. So distance learners, we're just doing a few so that it helps you with your blue packet. All right. You were taught yesterday that when you multiply, you can combine what's under that root. So I'm going to do the 3 times the 8, which gives me a 24 under there. And x to the 1st times x to the 5th is x to the 6th. Now I'm going to attack this just like I did number 6. Is 24 in my list of nice numbers? No, but there's 1 in my list that's living in it. What nice perfect square is living in 24? 4. So the first thing I'm going to do is go root 4, root 6, right? Break that 24 up into the nice one that I know. And then I still have the root x to the 6th. So let's see if you've got this down. What's this going to give me? 2. How about the root 6?
Nothing.
It's going to nothing. It's got to stay there. How about the x's?
That's the 3rd.
X to the 3rd with no leftovers. Because 6 divided by 2 is a perfect 3. Again, what if that had been x to the 7th? I'd still pull out the x to the 3rd, right? But I'd have one loner left inside. All right. Did you guys get to division yesterday? I think that's your today's. So I'm going to stop right here. And I'm going to have you guys pull out your blue packet. Distance learners, that's all you need to send me. They have work time now for the next 15 minutes. But I want to see what page you're on and kind of see if you need any help. I'm going to stop this and upload it.